It is time for everybody's favorite part of the section, applications. We're going to talk about some applications of polynomial functions. We're not going to do anything too fancy, but we are going to model real life situations, simple versions of it, of course, because this is a pre-calculus class and not like a super high, like fourth year or graduate level math class or anything like that. So it'll be kind of a simpler version, but we're going to model real life, which is my personal passion for math. That's where it comes from. I like modeling real life with math because you can do really powerful things with it. Specifically, I like doing things for like business and finance and stuff. Not usually for, well, I like using math for video games. Anyway, example 4. We have an oil slick, oh no, is expanding as a circle. So, you know, originally it starts like nothing, and then the oil slick gets bigger, and oh my goodness, and then the oil slick gets bigger, and so on, right? Every day it gets bigger in a circle like that, okay? And it's increasing, the radius is increasing by 20 meters per day. Let's write that down. Radius increases by 20 meters per day. We could even write that as a function if we wanted, but I'm getting ahead of myself. Express the area of the spill as a function of d, days elapsed from the original spill. It wants us to find, this is good problem solving strategy, write down what you know, write down what you're asked to find. Find the area as a function of d. Ooh, we can use function composition here, right? The area of a circle is pi times the radius squared. What's our radius? Well, it starts off as 0, and it's increasing by 20 every day. So, all right, on day 0, the radius is 0. On day 1, the radius is 20 meters. On day 2, the radius is 40 meters. On day 3, the radius is 60 meters, and so on. How do we write this as an equation? Well, the radius is just 20 times however many days have passed. So I have an area function in terms of the radius. I have a radius function in terms of the days. This is really function composition. This is function composition in action. 3.4, I think, 3.4. Okay, so how do we answer? Well, just plug this in. So area is pi times the radius squared. What's our radius? 20 times the number of days. And that's our unsimplified answer. To simplify it, we have to square this whole thing. Remember that, what is this? This is 20d times 20d. That's what it means to square something. 20 times 20 is 400. There's still a pi. D squared is d squared, and here is our answer. That is the area in meters squared after d days. Let's do another one. Here, we don't need this one anymore. I'll delete it later. A rectangle, example 5. A rectangle has a length. All right, I got through 4 letters. Nope, more than that. 5 words. And I know I need a picture. Let's draw a picture. A rectangle. Draw a rectangle. Has a length of 10 inches and a width of 6 inches. Anytime you're dealing with something physical and you can get a picture, make that picture. If the length is increased by x inches, well, how do we write that? So this length is getting increased by x inches, and the width is getting increased by twice that amount. The green is twice of blue. If blue is x, green has to be twice x, 2x. Express the area of the new rectangle as a function of x. All right, so now, right, we have this big rectangle. So what's the area of the big rectangle? Well, it's length times width. What is the length? Well, if blue is x and red is 10, right, the length is just x plus 10. Similar, right? The width has this red, which is 6, this green, which is 2x. Add them together, width is 2x plus 6. Well, multiply those together. The length is x plus 10. The width is 2x plus 6. This is our unsimplified answer. But we love simplifying. First, outer, inner, last, let's FOIL. The first is 2x squared. The outer is 6x. The inner is 20x. And the last is 60x. Combine like terms, and we're going to get our area is 2x squared plus 26x plus 60. That is our area function. And I will take this as a final answer, but it is actually a little bit better to write this in function notation. Right? This is area as a function of x, just like we usually write f of x. But here our function is a instead of f, so we'll write a of x. This is function notation. This is not multiplication or anything. And that's a great answer here. And that's applications. I do a couple more in the selected homework problem videos if you want to see some more of these.